Hi, I'm Shashank Manjunath, a scientist at Charles River Analytics and technical lead on this turbulence mitigation, error reduction, and increased contrast project, also known as Turmeric. While this topic is specific to turbulence mitigation, we have a number of different capabilities which may be relevant to a peripheral interest of yours. I invite you to come talk to me at our virtual booth and I can connect you with the relevant person. Thanks for coming to this talk. First, some information about Charles River Analytics. We're an employee-owned small business headquartered in Cambridge, Massachusetts, with a second office in Point Judith, Rhode Island. While our Cambridge office is more focused on software R&D work, our Point Judith facility is focused on hardware and testing and boasts excellent facilities for at-sea testing of various unmanned undersea vehicles. In total, we have around 200 employees. Traditionally, we've been heavily DoD-based, but have recently branched out into a variety of different areas such as medical technologies and augmented and virtual reality. We even received an epic mega grant from the creators of Fortnite in order to develop some of our AR and VR technologies, which we're very excited about. Charles River is made up of three divisions: Sensing, Perception, and Applied Robotics, or SPAR, Decision Management, or DM, and Human-Centered Intelligence Systems, or HCIS. This project is under the SPAR division, but we collaborate heavily between divisions here at Charles River. We've previously worked across the DoD with Army Research Labs, the Office of Naval Research, DARPA, and many other groups. If you want more specifics about the company, you can check out our website, www.cra.com. We have a number of Phase 3 projects associated with the SBIR program, as well as several standalone products. One I would like to highlight is AutoTrap. AutoTrap is a side-scan sonar automatic target recognition system used to identify mines. It uses machine learning to quickly and accurately identify mines and side-scan sonar returns. This slide is just a small sample of the type of work we do at Charles River Analytics. Feel free to stop by our virtual booth if you'd like to hear more about our work. Now, onto Turmeric. Digital imagery collected in the maritime environment frequently suffers from outside the camera distortions due to atmospheric turbulence caused by temperature and humidity gradients. This source of noise can't be corrected through the adjustment of camera and imaging parameters and requires post-processing in order to mitigate. For example, consider a camera operator attempting to read lettering on a ship using high zoom on a hot day. Atmospheric turbulence would cause blur and movement of the letters, preventing the operator or an image processing algorithm from rapidly identifying the lettering. Turmeric aims to mitigate this problem and allow easy identification of faraway objects. In addition to considerations of the turbulence noise itself, imagery in the maritime environment comes from a moving camera capturing a moving target. Therefore, any turbulence mitigation algorithm needs to run quickly and not require multiple frames of a target in order to display a denoised image. In this image, you can see a slight smudge on the horizon to the right side. A human or target recognition algorithm may classify this as an imaging artifact at first glance, but it's actually a ship off in the distance. Turmeric aims to make identification of targets such as a ship and the blurry houses on the shore to the left of the image easy for humans and algorithms to identify. Based on the challenges that Navy maritime cameras face, there's a need for real-time correction of the outside the camera issues caused by imaging in a turbulent environment. Turbulence can cause poor performance in downstream image processing algorithms, as it causes movement and can blur edges, which are frequently used as core features for image processing techniques. Turbulence can additionally cause operator confusion, as it can prevent the reading of text or labels on objects and imagery. Existing outside the camera degradation mitigation algorithms typically use multiple frames in order to find a single frame which has a good view of a given target. This approach is called the lucky shot approach. While this technique can be effective, it delays delivery of imagery and information to downstream algorithms and operators, as it requires the camera to collect several frames of a given target before the imagery can be analyzed. Furthermore, in a maritime imaging situation with a moving camera and a moving target, it may not be possible to correct several consistent frames of a single target for use by a lucky shot algorithm. Therefore, based on the drawbacks of existing image enhancement algorithms, there's a need for a real-time enhancement algorithm that works on high-resolution imagery, improves the performance of existing image processing algorithms, and which improves human operator perception of imagery. In essence, Turmeric aims to maximize the standoff distance at which meaningful information can be rapidly extracted from imagery. In order to effectively enhance imagery given the algorithm constraints detailed on the last slide, we've developed a generative adversarial network, or a GAN-based image denoising algorithm, which runs in real time on high-definition 1080p imagery. A GAN consists of two neural networks, a generator and a discriminator. For our task, the generator attempts to generate clean imagery from dirty imagery, while the discriminator attempts to discriminate between imagery cleaned by the generator and actual clean imagery of scenes not containing turbulence. The networks are jointly trained until the discriminator is unable to discriminate between the generated clean imagery and actual clean imagery. Only the generator network needs to be deployed, as it alone effectively cleans imagery. The discriminator is an auxiliary network only used for training. The Turmeric capability is currently at TRL5, and we're hoping to reach TRL6 in the near future. Aside from using a GAN for the image denoising task, another key innovation of Turmeric is the speed at which we are able to clean imagery. We use GPU-based optimizations in order to denoise 1080p imagery at 30 plus hertz. The system has currently been tested using two NVIDIA Quadro RTX 4000 GPUs, although we can adapt the algorithm to run quickly on a variety of hardware constraints. Turmeric is currently in the first option period of its Phase 2 funding and is on schedule. We are currently testing the system and have reached necessary speed metrics within the first year of the Phase 2 funding. We are currently working on adapting the algorithm performance for the specific needs of the Navy. While this is the current schedule based on our current funding, if more funding is available, we can certainly accelerate development time and deliver working systems ahead of schedule. Here, we have some key features and benefits of the Turmeric system. First, Turmeric only requires a single frame in order to mitigate turbulence noise for a given scene. This eliminates the need to examine multiple frames and reduces the latency between frame acquisition and presentation of information to the operator. Additionally, only requiring a single frame allows correction of moving scenes frequently encountered in the maritime domain. Secondly, Turmeric uses a generative adversarial network in order to mitigate the non-uniform blurring caused by atmospheric turbulence. This allows both turbulence mitigation and contrast enhancement and enables real-time processing through the power of parallel computing using GPUs. Furthermore, the discriminator network allows for development of complex denoising neural networks that can assess the cleanliness of imagery, as it assists in slowly teaching the generator network how to mitigate turbulence effects. Thirdly, Turmeric uses realistic physics-based synthetic atmospheric turbulence when training the GAN. To obtain this data, we partnered with the turbulence experts at L3Harris, who had developed this algorithm to simulate the effects of atmospheric turbulence on electro-optical imagery. Our algorithm relies on the training imagery containing images of the same underlying scene, one with atmospheric turbulence and one without. This is extremely difficult, if not impossible, to collect in the real world. Therefore, we partnered with L3Harris and generated the necessary training data to create a performative algorithm. Lastly, we performed a comprehensive analysis of model performance, including classic metrics such as cumulative probability of blur detection, also known as CPBD, natural image quality estimation, also known as NIQE, and more contemporary metrics such as learned perceptual image patch similarity, or LPIPS. Turmeric is able to quantitatively improve image quality as measured by all of these metrics. Turmeric is not only useful for at-sea applications. Any surveillance cameras which use high zoom can benefit from the Turmeric technology. We have so far made contacts with the Surface Navy, MVESD, and ONR who are interested in applying this technology to their needs. We are additionally working with L3Harris to transition this technology to their Farsight imaging system, as well as applying the Turmeric system to our in-house smart camera technology, where Turmeric will automatically enhance imagery for downstream object detection algorithms. We are interested in transitioning our algorithm for further government work. While much of the core development of the technology is finished, we require funding to work on integration. We have data sources to train algorithms for specific applications and can easily adapt our algorithms to particular computational constraints. We are additionally interested in partnering with commercial entities in order to integrate the Turmeric technology into existing systems. If you have such a system that might benefit from this technology, please come talk to us. Thanks for listening to this talk. Again, I'm Shashank Manjunath. Come see us for a demo, or feel free to contact me through email or phone if you have any questions. We have materials and demos in our virtual booth, but can set up some other time to walk through any specific capabilities that you are interested in. Feel free to contact me about other technologies at Charles River, and I'll get you in contact with the right person. Thanks again.